Hello students, we have first exercise problem of chapter 8 electromagnetic waves in this video. The question is, figure shows a capacitor made of two circular plates each of radius 12 cm and separated by 5 cm. The capacitor is being charged by an external source which is not shown in the figure. The charging current is given, it is constant 0.15 ampere. And from this condition, from this data, we are asked to calculate the capacitance and the rate of charge uh, of potential difference between the plates. I suppose it should be rate of change. It should be rate of change in potential difference across the plates of capacitor. Then second question is obtain the displacement current across the plates, and lastly is Kirchhoff's first rule valid at this point. Now we know that Kirchhoff's first rule says that at junction, the number of currents coming and number of currents going both should be equal, both should be same. So let us see if it is applicable here. But for now, let us start with the first question. So which data we are given here? Numerically, we are told that the radius of each plate, that is R, is 12 centimeter, that is 0.12 meter. Separation, small d, if we label it as 5 centimeter, that is 0.05 centimeter. Okay, now we know that for any capacitor, C is epsilon 0 A by D. So I can say that C is epsilon 0 pi R square by D. So first quantity we can find out C is available with this. Okay. Secondly, we know that C is equal to Q by V. When capacitor is being charged, obviously Q value is changing. So I can say that Q is C into V, and if Q is changing, dQ by dt, it is C dV by dt. Now, what is dQ by dt? dQ by dt is actually, if I consider this circuit to be connected with, say, battery like this, up to this point you have conduction current IC, and then in this region, though there is no flow of charge, the effect of changing electric field is just like current, which we regard as displacement current. Now, whatever is the effect of IC at, say, some point P here, similar is the effect of ID at some point, say, X, between the two plates. So these two, IC and ID, both must be very similar. So what is this dq by dt? You may say it is IC, you may say it is ID. So if I am asked to find out dv by dt, what I can do is I can express it as I by C. So that is the second quantity. Find out change in potential. So here is the rate of change in potential. Okay, and ID is IC. That is the third one. And what about Kirchhoff's rule? Yes, it is very much applicable. IC and ID both are same. Whatever is the effect of IC at some point outside the wire, same is the effect of ID at some point between the two plates of capacitor, and hence the two should have same value. Thank you.